you need to understand what code you need to write yourself and what you need to delegate to the machine, right? Like there is a quote by, I think, Warren Buffett. I laugh. Half of my investments are garbage, and I just don't know what half. So we need to understand what half we need to delegate and what not.
Hey there, welcome to Book Overflows, the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, we're excited. We got a special episode for you today. This is Kirill Bobrov here on the podcast, author of Grokking Concurrency. Did a couple episodes about it. Loved the book, one of the great, more technical books we've read. And we were really excited to have Kirill on the podcast. Doesn't do a ton of podcasts. In fact, he said this is his first one. And so kind of a great get for us here at Book Overflow. Awesome interview. Nathan, you want to give your thoughts on the interview, a sneak peek of what's to come?
Yeah, he's as much a domain expert in the interview as he was in the book. It was really cool to talk to a first-time, possibly last-time author, and then also talk about career development, concurrency, how to think through things as we're getting into the world of AI, and how to stay happy in your job. Just all kinds of cool topics that we explored outside of Grokking Concurrency.
Yeah, absolutely. Lots of cool stuff in this one. Always great. We love when we get to interview big names on the podcast, but we also love when we get to shed some light on some newer authors or some more technical authors. At any rate, stick around. This is Kirill Bobrov as he reflects on his book, Grokking Concurrency. Well, thanks for joining us, Kirill. It's a pleasure to have you on.
Hi, yeah, thank you for having me here.
Well, absolutely. And we're excited. We know that you don't do a ton of podcasts, and this is in some ways a Book Overflow exclusive.
Yeah, it's the first time I come to a podcast and somebody actually record me talking live in my second language. So it's probably would be a very interesting experience for me. So I'm not a native speaker, so forgive me for making pauses and think.
No, not a problem at all. We have plenty of authors who aren't native speakers. We just interviewed one the other day who isn't a native speaker, and that's I think that's cool about the tech industry. We get the chance to work with a lot of people from lots of different places. So we're excited to have you on, and especially excited because we love the book Grokking Concurrency. We try to maintain a good balance on the podcast between kind of like career focused books and very technical books, and so we had kind of done a lot of career stuff before we had read yours. And so we thought we really just need something that's just really meaty and really deeply technical. And Grokking Concurrency just filled that gap completely. What a great educational, we could rave about the book, and we will for the next hour. But I just wanted to get your opinion. So, I mean, what motivated you to write the book? And maybe if you want to talk about, was there anything in the industry at the time you decided to write the book that you thought maybe there was was there anything about the industry that prompted you to write the book?
Yeah, honestly, I think everyone jokes that every developer secretly wants to write a book, and I was not an exception. But for me, writing Grokking Concurrency, I think, came from the personal frustration. I couldn't find the clear, practical resource that I needed myself. So when I first started diving deeply into concurrency and asynchronous programming, I discovered that it's really hard and there is not a lot of solid practical information. There are a lot of great books on the topic, like Java concurrency, the concurrency in Go, and there are also foundational theoretical books from brilliant minds like Leslie Lamport. But what was missing was something practical, accessible, and not tied to any specific language. So I realized a lot of the knowledge was actually hidden inside the libraries like libuv, Boost, Tokyo for us, for example, and frameworks. I'm familiar with all the distributed frameworks probably. So Spark, Fleeing Beam, Apache Ignite, all of those frameworks, they have some kind of concurrency implemented, and it's all hidden away from the general public. And to really grasp concurrency deeply, you have to literally dig through like layers of source code, piecing together those like bits of scattered wisdom, I guess. So I wrote in the book that it's like trying to navigate the unfamiliar city without a proper map, and that's what I try to actually implement. That's what I try to write, a proper map, so you can kind of not waste time and take in like wrong turns in the city that you're not familiar with. So yeah, I started documenting everything that I was learning from the blog post, and gradually bringing it all together into a book, and then eventually I created this Grokking Concurrency book. So
what is it about concurrency in particular that fascinates you? I think that's interesting with software engineers. We all tend to gravitate towards one part of the field or another. Some people, it's, are really drawn by user experience. Other people as DevOps. I'm sure concurrency is the only thing you're interested in. But, to write a book, it's a big undertaking. So what about concurrency fascinates you?
Yeah, writing a book is it's really a deep work for usually coffee money royalties. And yeah, the funny thing about concurrency is that it seems simple at first and at the like surface level. There's APIs on different languages. They seem deceptively easy, but like underneath there is a very kind of intricate machinery, and you need to, if you want to understand concurrency, you need to expose that. You want to simplify it, I guess. And for me, this book is actually like simplification of the things. And what I've been drawn to concurrency is probably this complexity that is hidden away. It's like thing that I want to uncover and understand deeply, because like everybody, every developer right now is probably concurrent developer. We're all working with concurrency. We know that or not. Sometimes you work with issues that are concurrency related, but you don't understand that. So that's what I kind of see in the field, and that's what I want to bring to the community, to really understand what's going on behind some of the issues, at least.
Yeah, I really enjoyed this book because I read the Go concurrency book. I'm a Go developer, and that was sort of my introduction to thinking more deeply about it. But of course, Go has a very like unique flavor, both on how we talk about it and sort of the idiomatic patterns. And what I appreciate about this book is that I was able to take that existing knowledge and then expand the definition. I hadn't thought of it in this like broader context before. And so I really appreciate that about the book. My question is, go ahead.
Yeah, I just wanted to add that all of those books, they are really great. Probably the most famous one is the Java Concurrency in Practice or something. I think this is the name of the book. And it's going deeper into specific implementation, and sometimes you want to step back a little bit to understand what's the actual picture of the concurrencies, and that's what my bring is book to the table. Yeah, go ahead. Sorry.
No, this is great. I guess my follow-up question would be, you ended up choosing Python as the language, and I think that was a wise decision because I guess it's very approachable. But being in more modern languages that take sort of a more aggressive approach to giving us concurrency primitives, I'm curious about, did you feel like you had to write a bunch of boilerplate to get these examples in place, or do you still feel that Python was the right choice for the book?
Yeah, I can see that Python can be like when you actually read the book and you see some of the Python code, it seems seems weird, right, at the moment. Specifically, if you go to the later part of the book with asynchronous programming and stuff. And yeah, I've chosen Python basically probably primarily because I love Python, and this is my language of choice, and it's really approachable. Um, but yeah, when I started writing, I went back and forth a lot. Considered other languages like Java, Go, and Rust. But yeah, Python won out because it's intuitive and really approachable, and it's really, I think it's essential for teaching clearly. But yeah, you're right. It's sometimes awkward as you forcing concurrency onto a language naturally designed for sequential tasks, and Python is kind of still on the path toward more built-in asynchronous and concurrency programming. But yeah, looking broadly, I think a lot of languages, like for example, Rust is probably the newest one, and I was thinking that maybe Rust would be the good choice for the book. But the language is kind of still developing, so I decided not to go this route.
Well, I mean, a recurring theme on this podcast has been, we've talked about this with Brian Kernahan and Mark Richards and John Osterhout, is this theme of, as development continues, we keep getting abstracted away from the very low levels of it. It's like you said, like concurrency is kind of by nature abstracted behind all of these different libraries. And so much of computing handles concurrency for us these days. It's an interesting academic exercise, but what do you think is the biggest benefit an engineer would get in like their day-to-day life from understanding concurrency really deeply?
I guess like as Herb Shutter famously said, the free lunch is over. So meaning the processors aren't magically doubling their speed every year anymore. So today, the performance improvements we see in the industry mainly from leveraging concurrency, not like raw processing power. So this means concurrency is just like an advanced optimization technique. It's become like the fundamental like skill developers need to have in their toolkit. Like we all have phones. We have apps on the phone, streaming music, voice assistant. They all quietly like handling all different multiple tasks concurrently behind the scenes. So even if you are like a web developer using frameworks or JavaScript programmer relying like on browser features, concurrency is still there and it's still silently working under the hood. And you kind of still need to understand, at least on the like from the engineering perspective, what's going on behind the scenes at the broad level, at least. So yeah, some people I think argue you can safely ignore concurrency, like because of those frameworks, they can handle it for you. And it's true. Browsers and web servers often like abstract away those concurrencies, those complexities, but abstractions doesn't remove the problems. You will probably still see the problems. And as I said, interestingly, many developers encounter concurrency issues without even knowing it. They might spend hours like chasing bugs or I don't know, slowdowns that seem random, mysterious, and then discover that it's really a problem that was concurrency related all along. So yeah, and I think if you want to speed up your application, concurrency is probably one of the ways to go. And as a data engineer, you also probably see that data is growing and you need to kind of cope with that. in the most efficient way. And this is where concurrency kind of scales, because it's really a scalability concept.
Yeah, I've noticed that in my own career as I've been especially talking to junior devs, but even senior engineers sometimes, who lack the troubleshooting skills, because I feel like that's where a lot of times people get a real heavy dose of having to think about concurrency. Is they maybe aren't as familiar with idempotency, or they're not with worker queues or these other things that can run into these strange, all the locks and race conditions and other things that you start thinking about when you start dealing with this. I think the other one that kind of hit me was when I started doing a lot of data pipeline work, especially when like Airflow came out and there's a lot of other options now, people having to start talking about DAGs, like, directed acyclic graphs. I felt like no one talked about those. And that was sort of like a, computer science algorithms thing. And then now it's just like, we talk about DAGs all the time. I don't know if that's been your experience as well.
Yeah, as a data engineer, yeah, we talk about DAGs every day. And it kind of makes sense, right? You need to, like, for example, concurrency. And one of the probably the big misconceptions, the people who don't understand what's going on about concurrency, is that they think concurrency is about creating more threads and speed up applications, and that's it. But concurrency as itself is more about, I guess, communication and creating those, like, as you said, DAGs, the components and how they interact with each other, and cover this complexity and try to actually move this complexity around and tackle it in the most efficient way. So yeah, and yeah, we can talk about DAGs every day.
Yeah, exactly. Well, it's funny to see how many problems start fitting into these patterns. And I think, again, this is one of the things I appreciate about your book, is that there was this whole there was all these like sort of like philosophical pieces in there that talked about like, oh, here's the shape of work and here's how to think about right sizing the workloads with the sort of infrastructure that can run those workloads. And I hadn't thought of it in those terms, and it's given me a good vocabulary to talk to people about this, about what is an over optimization, what's the correct unit of work to divvy out. I have a question on feedback. So, what's the feedback that surprised you the most from after writing this book?
Yeah, I guess it's what I see is that it's really easy to underestimate how powerful a familiar metaphor can be in bringing the gap between like very abstract concept and real world like intuition. So because, for example, people, yeah, probably to answer your question, the most surprising thing about the book, a feedback for the book, was that people actually read it. Because the first person who I read this book for was me. I wanted to understand what's going on. And writing is probably the best way to actually learn something. And but yeah, as I've been saying, all the metaphors, they actually been really good for the readers. They give a lot of like positive feedbacks about actual like intuition to concurrency concepts, different components, and how you actually see the all the pictures, like the actual map that I wanted to create, like the practical map for the things. And so yeah, I guess that's kind of the answer.
Talk to us about the pictures. We love it when we get a good illustrated book. We're so deep into technical stuff here that when a book comes with lots of pictures, it's like, all right, nice change of pace. And your pictures were excellent, very informative. I mean, would you have done pictures for any book you wrote, or did you kind of feel that pictures were a particularly potent way to teach concurrency? I guess what kind of led to that decision?
First of all, the illustration was not done by me. It was my amazing wife that did those illustrations for the book. It was like working like that. I gave her a sketch and she created all those masterpieces there. But yeah, illustration was actually a huge part of the book just because of that intuition I wanted to bring to people. I wanted developers to understand really abstract concept. And I cannot do that right away, right? I cannot formally introduce different concepts because it would be probably very boring. And I created this like stories. I think my book is more of a set of stories, and to support those stories, I needed some kind of visualization so people can not actually see it, but actually feel the problem, the specific situation. Because when you feel something, you probably build a better mental models and better understanding on the concept. So this book is just storytelling with illustrations. I would probably compare it to do you know those like books for babies where you have this like science book for like small kids, like quantum physics for babies, for example. Like this is a ball, this ball has energy, all balls are made of items, electrons give energy, will fall down, this energy is a quantum, and stuff like that. It's really cool. So I'm a big fan of those books, and I think this is something like that for like grown-ups for grown-up developers who already have some kind of experience.
That's awesome. So were you saying your wife did the illustrations?
Yes. My wife, it was a family effort, I would say.
That's awesome.
And yeah, she actually bring all the pictures to life, and we created this concept of like octopuses. You've probably seen that everywhere in the book. And the idea was that, like in my mind, I always see concurrency as this like octopus with all different hands doing the same thing at the same time concurrently and stuff like that. So sometimes we need to go not just on the like very abstract level, the visuals of octopuses. We need to go deeper into the actual technical concepts. And it was really like quite a challenge when you want to create very cool intuition with some specific metaphor, because finding this metaphor for some complex concept or component, it's really hard, and it was kind of a big puzzle for us to solve. And honestly, it still kind of amazed me how we managed to pull it off.
That's awesome. How long did it take you to write the book?
I think it was more than a year, like a year and a half.
Oh wow!
But it's not like writing a book. It's not really an easy thing. You can think of it as just sitting down on your own and write, but it's not gonna happen. It's usually you write everything, you feel it's all done, it's finished, it's all cool. But then you send it to your editor or somebody else, or you reread it yourself, and you see that there are gaps. There's something that is maybe conceptually wrong, and you need to rewrite it again. So every chapter in the book was rewritten like 12 more times. I don't know. It's really hard to actually count how many times I rewritten all the different stuff and remanage illustrations and chapters. So it's really hard, and yeah, but it was fun.
So I feel like there's obligatory questions on AI that have to happen these days. Now that we have these AI coding assistants, we already see that lots of folks who are not initiated have a hard time thinking about concurrency and good patterns around concurrency. Are you optimistic, or do you have concerns about the AI generated code that might be touching these concurrent paths?
I think, yeah, I guess I'm in between. I still think that we engineers will still need to understand what actually means to write a proper concurrent code or any code at all. We don't really need to delegate that to LLMs, at least now. But but LLMs are great, and I think in the future we will have kind of different problems with that. Like, you need to understand what code you need to write yourself and what you need to delegate to the machine, right? Like, there is a quote by, I think, Warren Buffett. I laugh. Half of my investments are garbage, and I just don't know what half. So we need to understand what half we need to delegate and what not. And I hope that people will continue to reason about which problem worth prompt to LLM and which require a team of experts to architecture and create a solution. And I think concurrency is still on the later. So yeah, my prediction is that developers who understand concurrency, like at a deep intuitive level, become even more valuable at the AI era, because there will be critical reviewers, architects, and people who protect teams from like costly mistakes, obviously. And AI doesn't really replace the experts; it just simplifies it, making deep concurrency knowledge more, I think, essential than ever.
Cool.
It's been really interesting. I just left kind of the big tech world and have moved to a startup, which is moving at a much faster pace and is very on board with AI assisted tooling. And, it's pumping out a lot of code, like a lot of code. And then the other day I was doing some React front end work, and I was in a modal component that was 900 lines long. And it was just like, okay, maybe we can cool it with some of the AI generated stuff. So I think that's an interesting, the observations you have about concurrency, I think are similar with kind of everyone else's thinking about AI, which is like, yes, there are lots of benefits, but at the same time, like if you don't know how you're using it, like it still needs a lot of human assistance at this point, I'd say. A good strong hand on the wheel.
Yeah, I feel like currently at least we just do like the terminal command like rm-rf brain, and that's it. But it's not gonna work. We need to still think about the solutions, and maybe even deeper right now, because we need to become more senior, because we need to manage those junior LLMs better and what they actually put in production code.
Yeah, it's been fascinating. It feels kind of almost like you were trying to get somewhere by riding a bike, and then you swap out that bike for like a motorcycle all of a sudden. And, the motorcycle isn't going to drive itself to your destination. But I think kind of in a similar way, like it's hard to like really get seriously injured on a bike from like a speed issue, I guess I'd say. But like a motorcycle, like, yeah, you can lose control of that pretty easily. And it's funny with my current work seeing how that enhanced velocity can contribute to, I think, some out of control patterns. Talk to us a bit more about, so you write the book, and then, I mean, what has reception been like? I mean, you become a published author. Are you, has there been any big changes in your career? Any big changes, any feedback about the book that has surprised you or anything like that?
Uh, surprising things is, as I said, people actually read the book, because concurrency is really very like advanced concept, I think, and I would think that not everybody would be interested in that, but seems like things changing. Yeah, nothing changed. I still doing the same thing that I've been doing. I just can't put a author label in my LinkedIn, and that's it. And sometimes, yeah, people can actually reach out, saying some nice words about the book, and nothing aside from that, I think.
You got to be obnoxious about it at work. You got to, like, anytime there's a concurrency issue, you'll be like, as the author of Grokking Concurrency. I had a coworker who had a PhD in statistics, and I was like, it astounds me that you don't demand that we address you as a doctor. Because if I had a PhD, that is all I would do.
That's why nobody's going to give you one, Carter. You're out of control.
I maxed out at the masters.
So if you were going to go and write a second edition, is there any topics you wish you dived into deeper, or maybe you would even de-emphasize? Like what would you do to change the book in the future?
If I will write another book, I would probably charge more. But yeah, spending more time on the, I think, asynchronous concepts. It's the most complicated part of the book, and complicated concept still. And some of the pages in the book, they feel like there's not like a lot of sense, I think. Maybe I could make it more concise, maybe add more examples and stuff. Yeah, actually, one of the feedbacks for the book was to add more like exercises after each chapter. I've seen that feedback, so it's probably a good thing to add to the book as well. But honestly, another book sounds very weird to me. It's really weird thought. Another book, it's huge effort. I'm not sure I can take it, and I'm kind of a perfectionist, I think. So that's why kind of each chapter took me so long, and that's why I rewrite it so many times. So it would be a big challenge for me to start another book.
How do you find that perfectionism plays into your day-to-day work? I struggle with the opposite. I'm like a solid B+ student, and can sometimes need to like push myself to be like, we got to make it perfect. I mean, do you think it's a big boon? Do you think sometimes you would benefit from maybe not pursuing everything to a perfect degree? I don't know. What's your take on it?
Yeah, I feel like if you grow in your career, it definitely gives you this like itching, right? Because you sometimes not really write code or actually architect something with your own hands. You need to go and upload that to somebody else, and that somebody else can be not B but C. So it would be sometimes frustrating because you kind of feel like you need to intervene and do something with your own hands. So yeah, this is one of the frustrating parts. But you always have this. You can always come back. For example, I'm really a big fan of like optimizations. As a data engineer, it's one of the like probably big parts of the job that you need to be cost effective and actually efficient on your data pipelines. And when you write it, it can like you can ship the feature and it will be deployed in production, and then you kind of have this idea that you can optimize it, and it just can go back and optimize it, so it's not a big deal. So I'm usually do that. This is kind of a relief stress from my perfectionist mind.
Yeah, I love that. My background's in platform engineering and site reliability engineering, and I ended up getting to work with some data engineers on optimization stuff. And part of my job was to help make sure that we have good observability and good metrics in place. But every once in a while, we would find these 10x or sometimes even 100x performance improvements in certain areas, and it's so satisfying. It's so satisfying because you're like, and then of course you go like, well, why did we build it this really slow way before? But yeah, I love finding those. Those are exciting.
Yeah, that's why I love them as well. Like you feel the power, right? The speed and power of a specific framework when you actually optimize it to the level where it can like boost your performance or reduce your costs a lot. And sometimes it's happened, and probably more than this in data engineering, because we'll work in like petabytes of data every day, and every like 1% saving even can be a huge benefit to the company even.
Yeah, that's cool. Yeah, I was actually on a team for a little while that we had a huge spend on cloud spend, and so I was on the FinOps team working on ways that we could cost optimize. And yeah, that's like another interesting, you're not necessarily doing performance optimization. It's just like, oh, are we doing expensive queries on a column or database, or, these other kind of, maybe a little more grunt work. But of course, if you can free up, $20,000 a month or something, or $100,000 in a month, you end up being able to do a lot more research, or you get to like reallocate budget, and all of that's really cool too.
Yeah. And I think there is a notion of like 10x engineer, and I think one of the data engineers can be a 10x engineer just because he can save 10 other engineers' work or salaries and in a month, and it's a possibility. And that's you can even amplify that, and that's what I'm trying to do, like on my blog, where I can just write something about stuff that I can find out and like optimize something so other people can use it and or think about it differently. And so you can really share that knowledge and optimize other pipelines you don't even know that.
Obviously you've written Grokking Concurrency, you have your blog, Luminous Men, you're a data engineer. I think we have a lot of younger listeners who would look at your career and be really impressed and think, how do I accomplish what he's accomplished? What would be your tip to aspiring engineers, maybe people who are still students, people who are just starting out their career? What's the most important advice you could convey to them?
Oh, that's really deep question. I guess my advice for like any junior engineer in any field is probably do what you want to do. Like I don't like. Let me explain. I don't like working. I like writing code and solving problems, but I don't really like working. When I start working, when I do like mine 9 to 5, I feel like I will burn out very soon. So I want to start finding problems that I'm interested in, or doing something on the side, like some pet project that will boost my mood and my motivation and stuff. So for all the junior devs, just start some pet project. It will really boost your I guess perspective and actual knowledge of the systems that you will build in the future. Because if you just read a book, for example, Grokking Concurrency, you can implement every example there. But if it's not really going beyond that, it's probably not really useful. You need to apply that knowledge somewhere. You need to create some kind of platform system application that you care about. It can be something simple, whatever to-do list application or something else. But yeah, going through this like cycle of creating pet projects and trying new tools or solving your problems, just everyday problems, you can really boost your actual like practical like knowledge about stuff, of how computers work, of how systems work, of how they break. And yeah, because what I see usually when a new junior engineer starts in the team, for example, he usually don't read errors. So every error that's popping up on the screen in the logs, he can't read it. So if I hire somebody who already have like a ton of pet project, he already probably went through that cycle of reading the errors and Googling what they mean. And yeah, just start a pet project and you will boost your like engineering like career very, very fast. And one thing is that you should not really stop on any level, probably because IT is really going very fast right now, and you need to come up with an idea of how to actually understand which maybe tool or approach to pursue, try, and or read, and try it out. So yeah, this is one of the probably good advice that I would give to somebody.
I love what you say about juniors not reading errors, because I don't know why that's such a universal experience. Like your code breaks, the machine tells you exactly why it broke, and then no one reads it, right? And then as you get more senior, like maybe I should start listening to the machine and it tells me why it broke. And I also think, yeah, I like what you say about just kind of finding something you enjoy doing and just continuing to research it. We've talked about this on the podcast, but this is a field that really rewards deep research and deep understanding. It's very rare you'll meet someone who's done the work to understand a component of a system or a language or a framework very deeply. And you're just like, well, that was a big waste of time. I'm always very impressed by people who have deep understandings of any part of a system, regardless of, I guess, how critical it is. What do you think is the key to gaining that deep understanding? Is it just kind of keep hacking at it until it finally comes, or any particular strategies you recommend?
Um, so yeah, if you want to, I guess you're asking about like learning some specific concept or
I guess so, yeah.
framework or whatever. So yeah, you can just. I'm a visual learner. I usually want to like in practice see something happen, and so when you're interested, for example, in like framework, you can just start working on it and create some kind of like in data engineering, for example, data pipeline. You can create a data pipeline using some of the tools that's available and see the process and see where it actually where you ended up with. Like if there is some error, you will see and probably Google it and probably will learn more about the tool or about the ecosystem or about like general knowledge. So for me, it's just try and error. You need to try and then see what's going on, learn from the mistakes. It's one of the probably biggest and the most important, I guess, theme of life, to learn from the mistakes and then try again. That's it. That's simple.
The I was inspired with the question, and then I just lost it. So I'm gonna be on the spot for a second. Carter, if you've got a question ready, it's driving me nuts.
Well, I guess I was impressed. We're going to meta here a bit, because when I reached out to you via email and said, hey, we love the book, we'd love to have you on the podcast. And you said, you know what, this is not something I've done before, but I didn't you say you had decided you were going to do something that scared you every week, or what exactly was that? You sent me a quote. Do you remember what you sent?
I think it was from Elizabeth Roosevelt, that you need to do
Yes.
something that scares you. So that's what, I guess it's just it's not a thing, but it's something that I want to try on and do something new. Maybe not every day, but once in a while. And yeah, that's why I'm here. I'm not really used to showing my face and talking. with people alive and be recorded. So yeah, this is something that scares me because I can, in the internet, you can easily become a meme. And I don't want to meme my name to greatness, right? I don't want to become a meme.
I appreciate that, though. I think we're living in this kind of weird era where you see it with like some tech influencers, you see it with some founders where they're kind of like trying to meme their way to success. And there's kind of like a death of sincerity. We're a very irony focused culture. That's something Nathan and I believe in kind of strongly here on the podcast, is like, we're not going to resort to cheap tricks. We're just going to do the work, read the books, try to have engaging content, and you let the chips fall where they may. I mean, what is it about you that kind of grounds you in that idea that you're not going to meme your way to success, so to speak?
I probably just can't do that. I don't know how to do that. I'm really bad at marketing. For example, like I've been writing into my blog for like, I don't know, 5-6 years already, and I've never found a good marketing strategy because I don't know any. But yeah, and there's a lot of noise currently, and it's been for a while, I think, in the industry, especially with all the like LLM generated content flooding the web. It's easy to lose sight of like truly valuable, high quality resources. And I find that the book is actually kind of simply the one people usually put a lot of like effort and thoughts into. So yeah, I would recommend reading books more, and just sometimes, once in a while, just remove yourself from like resources from Reddit. Stop asking, stop reading, stop doing anything. Just read a book. Don't do anything else.
We live in a world of so much kind of disposable content. I know it's funny, as a parent, I'm dealing with things that like I never had to deal with as a kid. And so I kind of feel like anything that happened to me as a kid, I have like a decent playbook for like, okay, here's how I'm going to handle this with my kids. And then occasionally there's just something that's like, this didn't exist when I was a kid. And one of those things is like streaming. Like, my kids love watching someone play video games online, which is like not something that existed when I was little. And so I, as a parent, have had to try to balance like, okay, do we allow this? How much of this do we allow? What channels should we allow? But I find myself saying that to kids sometimes. They'll be like, hey, let's watch, they have this, it's like a family friendly one called The Basement. Like, we want to watch The Basement. I'm like, can we watch something that like people like put effort into, that isn't just two guys setting up a camera and talking to themselves while they played a game? I'm like, look at this Pixar movie. I'll show them the end credits sometimes. Like, thousands of people worked on this for this quality entertainment. And so that's one thing we really liked about books, right?
Or
Because it's
play
kind
the
of the same
video
effect.
game. Like that. It's
Yeah,
funny that
yeah,
you're
exactly,
like, I'd
yeah.
rather you play a video game than
Honestly,
watch somebody
right?
play a video game.
Because we've had to make those distinctions too, where I have to say, like, well, I don't mind if you play Zelda, because I think Zelda, again, it's a real work of art. I mean, it's a high quality craft, versus something like, I don't know, Candy Crush or whatever the Candy Crush equivalent is these days. Yeah, and so I totally agree with you, Kirill. This idea that like, I think that's why books are so important in this day and age, because it's something that takes a long time to make, and there's a lot of effort put into it, and you can tell, just like a lot of blood, sweat, and tears, and it's a real craft. And so we're always very grateful to people like you who do the work and actually write the book. And then we just, do the easy part and read it. But I think it makes a big difference.
Yeah. I think there is a quote, I think, from one of the books. Like there are 3 Buddhist ways to watch TV. The first one is to watch with the sound off, focusing only on like images and stuff. The second one is reverse. You listen to the audio without any pictures. And the third one, the ultimate way, I guess, is to watch it with both sounds and images turned off. And eventually you will discover the true nature of television. So yeah, there is a joy in missing out. That's what I'm trying to transfer to people.
Yeah, that's really cool. It reminds me of there's a word I'm obsessed with that in English that most English speakers don't know. So maybe I'll teach you a word. Autotellic. Are you familiar with this term?
No.
Okay. So Mihai Csikszentmihalyi, who wrote a book on creativity, he's written about information workers and stuff. Passed away now, but he talks about our autotelic pursuits are the intrinsic motivation pursuits that we grow for our own sake, right? And he basically says it's the highest form of creativity because it's not an extrinsic. There's no external motivation like, clout or prestige or, these other things. You do it because you're deeply interested in it. And I think those of us in technical fields, if we're lucky enough to find a niche or some type of carve out some place that there's room for craftsmanship or there's room for you to be deeply creative and deeply explore a topic, and you keep doing it because you love it, and you also happen to get paid for it because you're doing something useful for other people. That's this sort of perfect feedback loop, in my opinion. At least that's what I've followed. And hearing you talk, it seems like this has been similar for you, of not wanting to work, but actually being able to get to experiment and build things. So yeah, I think there's a way to describe it. It's called autotelic pursuits. I'll send you a link to it because it's to me, it's an interesting topic, and he goes into a lot of other fields and things as well.
Cool.
Yeah.
Well, Kirill, I mean, we've talked a lot about your book, but do you have any books you'd recommend to our audience? Anything you've really enjoyed, and fiction, nonfiction, tech, not tech, just anything that you think our audience might get a kick out of?
Yeah, honestly, I'm a bit hesitant about recommending specific resources these days. Just not because there's some good ones out there, but because we live in this time of enormous information overload. But I think after my book, of course, you need to read the Martin Kapelman Designing Data-Intensive Applications if you want to actually go into the data engineering kind of thing.
There is no book more requested by our audience than Designing Data-Intensive Applications. We only are holding off because we hear there's a second edition coming out this year.
Right.
But anyways, sorry, not to interrupt you, but yes, everyone, it's a classic.
Yeah, there is a reason why it's been recommended to you guys. It gives you a deep, intuitive understanding of complex data systems. Another probably in the same theme of data engineering would be Data Engineering by Joe Race. It's just about the actual, as I've described the map of the concurrency. Joe Race and Huxley, they describe the map of the data engineering field in very accessible terms, and it's really cool. It's one of the O'Reilly's books. Yeah, but aside of probably technical resources, I love recommending classic literature that probably enriches your broader thinking, I would say. There is one book I love, and probably all my friends know that it's one of my favorite books, and it's Lewis Carroll's Alice Adventures book. It always resonates deeply with me, and I've been reading it I don't know, for 10 years already, and reading and reading, and it's always something new you uncover there, some specific metaphor that resonates with you. There's an idea, I think in one of the books, about it's called the Red Queen's Race. Maybe you guys familiar with that? It's probably one of the popular ones. There is I think they're in the palace of a Red Queen, Alice, and there was a race where you need to raise a queen or something, and the theme of that is that she actually run as hard as she can, but she cannot really go anywhere. So when she stops, she's going back. And that's what I'm kind of feeling in the modern IT world. You have to run just to stay in place. And it's really, I guess it's one of the metaphors that really goes deep into the software engineering. Yeah, aside from that, probably one of my recent James Joyce Ulysses is another favorite. It's very complex and challenging, but it's really interesting to read. But yeah.
No, I love it. We need more good classic literature. I'm not great about reading classic literature. I read a lot, but I suffer from too much of a recency bias. Well, thank you so much for coming on, Kirill. It really was a pleasure having you. And we really, really enjoyed the book. We have a couple episodes on it, which we'll link in the description. And yeah, you can always find us on Twitter at Book Overflow Pod. You can contact us at contact@bookoverflow.io. I'm on Twitter at Carter Morgan. And Nathan has his newsletter, Functionally Imperative, at functionallyimperative.com. Kirill, anything you want to plug for our users? Your blog, or do you have a Twitter?
I have a Twitter, but I'm not really active there. My blog is probably one of the resources if you want to reach me. Yeah, aside from that, yeah, just go enjoy the concurrency book. I'm not sure if any other book will come from me soon, so.
Well, we'll enjoy this one while we have it. And, if you write another one, reach out to us because we'd love to read it. Sure. Thanks for listening, everyone. And thanks again for stopping by, Kirill. We'll see you guys later.